I grew up making stuff. My dad had a bunch of tools laying around the house. And so from early on, I was just making things. I just can lose myself in the physical act of moving and cutting material. I'm Ruben Margolin, and I make kinetic sculptures. They're something that you recognize there in nature, whether it's, the billowing of a tarp in the wind, or, birds moving, or the surface of water. It's not like I'm trying to copy nature. I'm trying to somehow relate to it. And if I can make anything that has that same quality. When I moved into my shop, I looked around and I saw how high the ceiling was. And so the first thing I did was build something that was suspended overhead and didn't use up any of my floor space. On the spiral wave, the original concept came during a rafting trip. Every time you paddle, there was that spiral sort of eddy coming off the back of the paddle in the water. And after 10 days of looking at that thing, I had the spiral wave more or less figured out. So then I came back here to my shop and drew specific shapes and designs for the various components. And I have this old redwood that came from an old deck. It's got 30 aluminum arms, which then drop down through, hundreds of monofilament down to a sort of flower funnel spiral. And it is just incredibly delicate. And so it means that the spiral wave almost looks like it's floating. Maybe in '96, I saw a caterpillar, and I could see how it moved. And I thought, wow, that's cool. The caterpillar was very mechanical and almost robotic. So I kept thinking the caterpillar would be so much easier to make if, instead of being cut in half by the ground, it actually went through the ground like that. Then it would be just a simple sine wave. And I was like, how do I do that? The hexagonal wave is originally inspired by the shape that a drop of water makes when it hits water. And you get these sort of circular ripples coming out. The hexagonal wave is 18 feet in diameter, and it's made of cardboard tubes that are taped at the ends with electrical tape. It's really low tech, and the tubes are really lightweight. And the tubes are all hanging from Dacron string. You can see in the center there's a rotating white knob, and that knob has all the strings attached to it. And as that turns around, the strings get pulled in a sort of sine wave, and that sine wave is distributed down through that grid. Part of what we had to figure out for this installation was how to physically get the hexagonal wave up there. The roof is 50 feet off the ground, and to get up there I had to climb up a rope and then use a whole bunch of mountaineering hardware and webbing in order to install the hoist motors just to lift the wave into place. Being a sculptor, I'm really just in touch with stuff. This is urban ore, and it's just one of the best resources for artists. It's got tons of junk. I like, just wood or metal. I mean, these just have tons of potential. They're wiggly, they're sort of mechanical, they move. Because the sculptures I've been making are so repetitive and they have so many identical parts, I'm particularly clued into what's available that's inexpensive and I can get lots of. And these are really cool. I mean, I think they're for a stair, like a baluster possibly, but they make really nice, I've used them for levers on the wave, and I put a bearing inside there and they worked out really well. I mean, they're kind of decorative and they're straight and they're strong and they're all cut to length and they're clean. These wave sculptures, they're not run by a computer. They're completely mechanical. And the process of making them is also sort of an older fashion drawing on a drafting board. It seems like for every design that I have, to get to that design, I would have worked out 3 or 4 designs that didn't work out. So in one way, I feel like I'm just working on the same sculpture over and over again in different permutations. A lot of what I'm doing making the sculptures is adding together motion. And so one way of adding together motion is by using pulleys. And so this camshaft over here, it makes a wave going in this direction. And the one over here makes a wave going in this direction. In order to make a sculpture that's fluid, it has to be made up of lots of little parts. And the more parts you have, the more fluid of a curve you can get. The square wave has, I think, 144 wooden dowels down here and maybe 300 or 400 pulleys. Every single pulley and cable and motor have to work. And if one little thing in here isn't working, then the whole thing just, stops. There's times, when I'm out just looking at the water and I'm just blown away. I mean, right now, these are like totally beautiful examples of linear waves. The pelican jumps in and it makes those round waves that are then going out through the linear waves of the reflections of the boat mast. That's far out. If I can even get like the smallest part of that into a sculpture, then it's going to be a successful piece. So right now I'm working on a wave that I think will be called the linear wave, and it is an experiment in trying to add up different wavelengths. One of these big wheels over here is going to make a wave with 3 peaks, and the other one is going to make a wave with 4 peaks. And you add it together, you get a new sort of wave, and this is what I'm trying to make right now. This is the end pieces for the linear wave, and I'm drilling holes all around the perimeter of it, and then I'm going to route out another circle so I have a donut, and there'll be 2 of these at either end of the wave, and they have plastic pieces that will pop into there for the strings to go through. I try to make everything myself, but every once in a while, I just start thinking, if I just had this right shaped thing, it would make life so much easier, and I can't get this piece of tubing and bend it into a circle because I don't have a ring roller. Man, they're perfect. Hard to make?
They were tricky.
They were?
Yeah, keeping them true and
They
straight.
look really straight. And the guy down the street has a ring roller, and so, like for right now, for the linear wave that I'm working on, I'm splurging, and he's making me 2 rings that are just going to really help the design out. I guess the biggest mystery when I'm making one of these waves is whether or not it's going to be interesting, whether it's going to be fluid, whether it's going to be beautiful. And there's a lot of time where I'm just sort of sitting there like trying to pull these movements and mechanical parts together. And then at a certain point, it feels just like it's starting to gel. And then you start to see it for the first time. And then there's a moment where you turn it on and find out what you think of it. It's more fluid than I thought it was going to be. The strings are more interesting than I thought they were going to be. I like the strings a lot. It's it's almost back to the caterpillar. Actually, it looks suspiciously like the caterpillar, doesn't it? Maybe I'm still making caterpillars.
Waves have the power to mesmerize and pulverize. There's a lot of energy crashing onto our shores, and some makers are trying to harvest it. In 1974, Stephen Salter invented the first wave power device in Scotland. Its bobbing motion earned it the name Salter's duck. As waves rolled the duck back and forth, shifting water levels inside spun a turbine that generated electricity. At the time, the government favored nuclear power, and the Salter's duck project was dead in the water. Today, wave power is surging back. One wave power device is a 400-foot sea snake, the Palamas. When waves hit, each of its many joints resist, forcing pressurized oil through a turbine. Huge wave farms are planned and could someday supply more than 10% of the world's electricity. Surf's up!
Major funding for MAKE is provided by Geek Squad,